Okay, we're going to talk about cubed roots and rational exponents, and another way to say rational exponents is fractional exponents. A cube root means that the index or the root is 3. In this case, it should be written down for you. If it's squared, it's not. And we're asking the question, so we want to know when we do a cube root, what number cubed, actually this cubed, gives us 64. Well, I'm going to go over here to my perfect cubes table. So here's my perfect cubes table. And I'm looking for something that is cubed and gives me 64. So when I go over here, I can see that something gives me 64 in my perfect cube. So 4 times 4 times 4, which is 4 cubed. So here, my answer is going to be 4. If I take 4 and I cubed it, I get 64. Okay. For the next one, I'm doing the same thing. Again, I'm looking at my root or my index, and I'm asking the question, what number cubed gives us 27. Okay. Well, if I go over to my perfect cubes table and I go, well, 27 is here, so I want to know what gives me 27. Well, 3 times 3 times 3 gives me 27, or 3 cubed. So here I'm saying that if I take 3 and I cube it, I would get 27. So my index is, I'm trying to do the opposite of cubing it. It's like what number the base be. Okay. So the next one, it's asking me, because I have this index of 3, what number cubed gives us 125. Well, if I go up to my handy table here and I go, well, here I've got 125, and 5 times 5 times 5, or 5 cubed, would give me 125. So I'm going to say, well, that's the same as saying I've got 5 cubed, right? That's what that would be. Okay. So we're going to be able to write this as powers. I want to be able to use this radical and rewrite it in terms of powers, and this is just notation. And when I'm writing something as powers, I want to remember that I can look at this as if my index is a root. So here's my tree, and I've got little roots over here off my tree. And I'm going to say, well, my index right here, this index, well, that's the same as having a root 3. And I know my roots are at the bottom, so it's going to be at the bottom of my fraction, and that any number that does not have a power on it has a power of 1. Okay, so I can rewrite this and say, well, this is the same as saying that I have 64, and the root is 3, so the root would be in the bottom, and the power is 1, and the power of 1 would be in the numerator. And the next one, if I'm looking at this, well, I have this 27, and I know that my root is 3, so it's going to be in the bottom, and that my power is 1, and it's going to be in the numerator. And the next one, I have 125, and my root, again, roots are going to be in the denominator here, so that's my root, and my power is going to be in my numerator. So this is how I would write this in notation. If I wanted to simplify this and actually find the answer to this expression, what I could do is I could do it in terms of factoring, or do it in terms of what it means in terms of powers. So I'm going to rewrite my cubed root of 64 and rewrite my cubed root of 27 and my cubed root of 125. And I'm going to write them in terms of their powers in the radicand. So this is 3, and 64 is 4 to the third, and 27 is 3 to the third, and again I'm looking up here, right, my 3 to the third and my 4 to the third, and my 125 is 5 to the third, so I'm going to say, well, this is the same as 5 to the third. And I can use this rule that I can put my root in my denominator when I write this as a fraction, right? These roots go in the denominator, and that the powers, well, they go in my numerator. So this is going to go in my numerator. And when I rewrite this, I'm going to say, well, this is the same as saying I have 4 to the 3 over 3 and 3 to the 3 over 3 and 5 to the 3 over 3. Well, 3 over 3, well, here, 3 over 3 is just 1. And I can say this is 4 to the 1, and this is 3 to the 1, and this is 5 to the 1, which is really just 4, 3, and 5.